Good afternoon, everyone. I'm the speaker for today. This is season FANG. For some reason, I designed this season present by English, but my season complete. You can ask me by English or Chinese. Thank you. So let's start the season. Today, I present season is introducing Postgres as a vector database. So let me talk about the agenda. First is the introduction to vector in database. Second is introduction to PG vector. Today we are to present. PG vector is a Postgres extension. It lets Postgres can use the original vector data type. So we continue to talk about the use case of the PG vector and the installation and setup, because PG vector need to make install so that Postgres can use it. It's not original Postgres extension like UID, and the rest is basic usage. And we'll talk about the performance consideration like index, and we'll talk two kinds index technologies, and finals is a conclusion. Let me talk about the introduction to vectors in database. Why are vectors? A vector is a list numbers representing data in multi-dimensional space, like in this array is 1, 2, 3, 4, 5, or 0.1, 0.2, 0.3, and vectors widely used in machine learning and AI of the data representation. For example, word embeddings and image pictures. Word embedding are natural language processing technologies to use to convert text into the numerical vectors. And vector in database, the role is enable infatuate similarity search and store high-dimensional data, install and set up. And second evaluation, from the basic data storage to supporting complex AI operations performance considerations. Let me talk about understand the vector. This picture maybe can. Okay. In previously we talk about the vector database. Vector database is a database optimized for storing and querying high-dimension big data, and like example, we did 1, 2, 3, 4, 5 or 0.1, 0.2, 0.3, and facilitate fast simultaneous search and retrieval in AI applications. And how they work is widely used machine learning and AI for data representation. Example is the word entering, image pictures, and user profile. Vector in database, we talk about the storage is a specialized data structure for handling large vectors, and search algorithms like near list, neighborhood search, and to find similar vector affinities. So we talk about the advantage use the vector database. Especially speed. First is the speed. It's the optional for rapid seamless search even with the massive datasets. Massive datasets means like the social media user interactions, post comments like in Facebook or X, other social medias. And second, integration. The same as with the machine learning AI directly support models and organizations used in machine learning and AI. Second is the complementarity can work alongside traditional database. And agility. First, the precision. Enhance agility in finding the similar data points. Second, advanced aggregation uses technologies like to cosine symmetry and L2 distance and etc. L2 distance is a measure for measure strange line distance between 2 points. Next. In this slide, we introduce the key use case for vector database. The recommend system is example is a personalized product recommendations based on the user behavior vectors. Second is image and video retrieval. Example, find image similar to given image using feature vectors, like find picture with picture. And third is natural language processing. We also mean this is NLP. Example used in simulated search for documents or keywords and using word embeddings or words in word disambiguous. And the third is from detection. Example is identifying the unusual patterns in transaction data vectors. The final is health case. Is to analyze the patient data vectors for personalized the treatments. Next. When we talk about the challenge in traditional database. First, the lack of the negative vector support. Traditional databases are not designed for the high-dimensional data. And second is the performance issues. Poor performance with the large-scale vector similar search. And final is the complexity. Difficult to integrate machine learning workflows with existing relational database. So we talked about the point today we want to present is the PG vector. What is the PG vector? PG vector is a Postgres extension enable vector symmetry search, and PG vector is a bridge the gap between the traditional database and the vector data needs. The PG vector key features is suppose vector data type and operations. I speak again, this is very important. PG vector let PostgreSQL support vector data types and operations. And second is offer interesting technologies for faster retrieval, and we will talk later. And we will talk about why we use the PG vector. First is the same as the PostgreSQL integrations, because I just said PG vector is a Postgres extension, so it is a high compatibility with PostgreSQL. It's until existing PostgreSQL tools and skills, and combines the relational and the vector data effortlessly. Second is the performance optimizations. The fast similarly search with the advanced indexing and efficient handling of the large data sets. The third is the flexibility and the scalability, adaptable for divisor in the strategies and the applications, and scale with the growing data needs. So we will talk about the key feature of the PG vector. First, we say before is a vector data type. It's a native support for storing vectors with the PostgreSQL. Second, is the simulability for the search functions. Implement in dictionary methods like L2, cosine simulability. L2 we will talk previously, so I don't explain in this here again. The third is the advanced indexing. Abstraction like the invert file we call IBF or the hierarchical name small word we mean HNSW for operationalized search. The final is the SQL integration. Allows SQL queries using vector operations. So you don't need another language to use vector in PostgreSQL. So we talk about the use case of the PG vector. First, in machine learning and AI to store and query model embeddings. Second is enhance the search engines to improve search revenues with the vector queries. The third is the personalized use experience. Tidier content recommendation based on user vectors. The final is scientific research to analyze high dimension data efficiently. So we talk about how to install and set up the PG vector. PG vector is a repository in GitHub, so you can prepare a GitHub account and you have installed PostgreSQL. The PostgreSQL need version is 12 or higher. So let's have the installation steps. You can use in Linux terminal or Windows command lines. You need to clone and compile the source code. So you need to install Git additional. So the install step is first Git the source code from repository. The second is go to the dictionary of the source code. The final use the make tool to make install. If the next step is successfully, you can use this SQL command to create the vector extension. It means you can use vector in PostgreSQL. This SQL is a create extension vector. So when we finish install and set up, we can use the general SQL with the vector. For example, when we create a table with a vector, we can use the simplest DDL like create table, table name, the clone name, data type, and specifying key. And if you use the clone with the vector, you can spec a name and you can direct use vector, means this clone data type is vector, and finally is the length. So we complete create table, so we can insert the insert SQL is like that. We'll insert into clone name with values. Values so like is array 0.1, 0.2, 0.3. And when you finish the inserting, so you can performing the similar search like this SQL command. So let's start from items ordered by the embedding. It means it's vector column we create is similar to 0.1, 0.2, limit 5. So we talk about vector, so we will talk about performance considerations. Performance is a key. When dealing with the high-dimensional vector data, efficiently retrieval and search are circular, and the role of indexing. Indexing is a primary method for improve for the performance for the vector search in database like PostgreSQL with the PG vector. And in indexing technologies, why index matter? First, fast retrieval. We talk about more and more time to reduce the time computedly to finding similar vectors. Second, efficiency. Handle large data sets efficiently without performance bottlenecks. And there are two types indexing in PG vector. First type we call immediate index, also means IBF. It means break data into clouds for the efficiency searching. Second is the hierarchical numerable small word. We also mean HNSW. It means use a graph-based approach for quick semantic search. So we introduce the IBF index. The IBF index is break the vector space into the multiple clusters and perform search within the most relevant cluster. The simple example scenario is you have to the data set of the 1 million image represented by vectors. If you without the IBF index, you will search through every image for a match is time consuming. With IBF, you can use the clustering that image divided into the 100 or more clusters, and search fast with the identity the closest cluster based on the query vector. So this is a SQL in the example. If we want to index the IBF, the index, we can use this SQL. And this expression is two keywords. The first keyword, IBF flash, is IBF indexing method. Second keyword, vector L2 OPS speaks the L2 distance matrix for similarity. Second is the HNSQ index. HNSQ index is a contrast graph where nodes are connected based on the similarity. It transmits the graph to find the nearest neighborhoods. The simple example, social networks need to suggest friends based on the similar interest is used in vector types. If you don't have the HNSW index, you use the linear search through all user and find profile. But you have the HNSW index, you can use the graph construction. User nodes connections are based on interest similarity. And second traversal, the quick navigates the graph to find personal friend match. The final efficiency offers high accuracy and speed even with the complex large data set. And we also have an example if you want to create a HNSW index. This is a SQL example. And there are also the two keywords. The first, HNSW, refers to the hierarchical neighborhood small word index. The second, vector L2 OPS, speaks the L2 distance matrix for similarity. So this is the conclusion. PGVector offers a powerful indexing technologies to enhance PostgreSQL's compatibility with vectors. And this season is over. If any questions?
好 ，sorry， 好，我比较好奇的是，刚刚两个提出来的 case， 一个 IVF 的方式是把查询的过程分散成 cluster，
对，
然后HNSQ 是用 graph 的演算法去查。那我比较好奇，这两种是只能择一吗？因为一个看起来是用机器去加速它，去做 indexing， 然后另外一种是演算法做 index。
目前看起来是择一，不过这边我会再去确认一下。
那你有比较建议，就是如果以 case 来讲的话，什么样的 case 会比较适合 IVF 吗？因为刚提到的这边是
以我实际的情况是可能，看情况可能每种都要 tuning， 就是看你的情况为主，因为可能根据你的环境，还有或是你的硬体或软体的不同的情况下，有可能就是它这个地方没办法发挥得很好，所以我的结论就是要视情况而定。就可能，如果你的硬体都是完美的，就是无瑕的话，就是可能是以它上面的建议为主，或是你自己可以选择其中一种来做评价。这是我的回答。因为我自己也遇过说，很多地方加 index， 然后以为变快，可是其实并没有。那很多原因是在硬体或软体，或者是比如说是在瓶颈或者其他的部分，所以这个部分可能没办法给你一个明确的答案。那我们这个时候会后再谈，谢谢。
好，感谢。
有其他问题吗？好，没有的话就谢谢大家。